Welcome to my build video on tutorial on building the my Mark IV redesign of the NanoHack 1.0 mask. Now, before we go any further, I just want to get two things out of the way. One, if you haven't watched the intro video to this series, you really should. It introduces the ideas as to why I felt I needed to do a redesign of this mask, and what you should and shouldn't expect it from it. Also, I need to make this disclaimer that I always make because it's important. I am not a scientist, I am not an engineer, I am not a medical professional. And I don't know actually if this mask is functional or might be dangerous because I can't test it. I don't have the kind of equipment to do that, and it's even more difficult than usual because we're all socially distanced and our supply lines are all messed up. So take that disclaimer for what it is. That being said, I think I've actually taken what was a disastrous design from NanoHack and made it actually pretty functional and worth looking at. All right, so the Mark IV is more advanced than the Mark II in two specific ways. The Mark II, I understand, is designed to be makeable by people with basic 3D printing supplies and basic crafting tools. The Mark IV steps up a bit and steps away from that and uses some more advanced 3D printing techniques and capabilities that not every 3D printing enthusiast has access to. Principle is the use of TPU plastic, which is flexible filament. By using flexible filament, I've been able to engineer an actual 3D printed gasket for the back of the mask, which works, I think, better than the other gaskets. It's also more controllable because it's actually designed as opposed to just custom built every time. And the other place that I've used TPU is in this TPU O-ring that I've now integrated into the sort of stack of items that we're putting into the filter cylinder. So when you put, and I've also updated, though this will work for the Mark II too, but I've updated the filter ring design with these little standoffs that keep the filter ring from hitting the end of the cap and potentially blocking some of its inlets. So when you put this thing together now, you take the filter ring, put it with the standoffs up front into the cap, push it to the end, and then you take the O-ring, put it on top, and the O-ring, when it's installed in here, keeps any air from seeping around the filter, which it wasn't, I don't think it really was seeping around in the 2.0 design all that much, or in the Mark II. But it was still technically possible, and I figured, well, if you can put an O-ring in there just to make sure, I might as well. So that's what I did, since I have TPU to work with now. So this is the Mark IV mask. Again, the two big things are the TPU gasket and the TPU O-ring. But also, when I build this, I'm going to use my 3D printing pen, and I'm going to use my heat gun, which are things that more advanced 3D printer enthusiasts and crafters and makers are more likely to have. And they make making this thing more effective. And I purposely stayed away from them in the Mark II videos, but I'm going to use them in this video. So before we drone on anymore, let's just go and download some 3D files. All right, so here we are at MakerBot's Thingiverse website. That's THINGIVERSE.com. And we're going to download my designs. The easiest way to get to my designs is just do a search for my username, which is B as in Bradley, J as in Jason, F as in Friedman, 200. That's BJF200. Hit enter and it should pop them up. Now for the Mark IV, we're going to download all of these files, but not the advertisement in the middle. We're going to pull the My NanoHack Redesign, which is the base of the mask, which is common with the Mark II. We're going to pull the cloth filter holder, which also has the O-ring design in that, so you're going to pull all those files. We're going to pull the NanoHack styled face gasket, which is the big TPU part that we're going to print, so you want to pull that down. We're going to pull the NanoHack filter cap with more flow and knob. And then also, at last, we're going to grab this mask adjuster flattened, which is just a adjustment I made to Hewlett-Packard's release of their mask adjuster. I just flattened out the bottom so that it could print without support. Otherwise, I didn't really design it. I just modified it. But we still want it, the mask adjuster flattened. Okay, so that's all 5 files. Get all the files for each of them and download them to your machine because next we're going to slice them.
All right, so here I am inside my slicing software for my 3D printer, which is the Prusa Mark III. This is not going to be a full 3D printing tutorial, so it doesn't matter if you use this printer or not. I'm just going to bring in the PLA parts and lay them out and slice them, and use that as an opportunity to talk to you about some of the printing considerations for some of these parts in the prep stage. So first, I'm going to bring in the actual mask itself. Okay. Next, I'm going to bring in the cap. There's the cap. Next, I'm going to bring in 2 filter holders. I'm going to bring in the offset versions of the single ply and dual ply filter holders. Okay, they both popped in. And that's all there is for PLA for this version of the mask. So I'm just going to quickly lay them out. And they all fit on the plate fine. And now I'm just going to go through and make a couple of minor adjustments. For support, only one of these parts needs to be supported. The mask does not need to be supported. These threads print fine without support. The 2 filter holders also print fine without support. If you have adhesion issues, you might want to try a brim on them, but I haven't needed a brim on either of these. The cap, however, it's my one regret in all of this, is when I added the knob, it pushed the whole thing off the surface, and so it does need support. So inside of Prusa here, I'm just going to add a support material modifier. I'm going to turn on support, and I'm going to tell it to support on the plate only, because that works fine for this one. And so that's all the support I need to set up. I print with 20% infill. I generally don't have a problem. The only parts that actually get infill are the inner part of this filter ring and some parts of it, like the knob on the actual cap. The main part of the mask, you should be printing with enough full top and bottom layers that it should never actually get any infill on the main body part. And the 2 filters are too thin to actually receive any. I am going to print this at 0.15 millimeter layer height in quality mode, but I have printed these in 0.2 millimeter layer heights without any problems. I'm printing in Prusa PLA, not that that really matters, and so that is all good. So I'm going to hit the slice button and just make sure that I'm getting what I think I should. Looks right to me. I'm just going to take a look at the individual layers, especially down in the mask, and just make sure it's not doing any infill, which it is not, and they're all solid layers. So this looks good to me. So I'm going to dump this out to an SD card and take it to the printer.
Alright, so here I've got my SD card ready to go, and behind me is my printer, my Prusa Mark III. So before we start talking, I'm just going to get this thing printed. Alright, so it's going to heat up and load the filament and go through its process, but the most important thing it's going to do is it's going to use its bed sensor to measure a 7x7 grid to make sure that it gets a perfect sort of even layer adhesion on that first layer of the mask. And that's probably the most critical part of this print. That mask is wide and it's flat, and that first layer, which is just going to get printed solid on the bottom there. If your printer can't really accomplish that level of sort of solidness on the first layer, the print may be problematic. It may become difficult. If you really need to, you can print on a raft. It's not my preferred way of doing things, but it should work. The design won't be particularly have a huge problem with the raft. But the most important thing is, and the place where this print will fail, if it's going to fail, is going to be on that first layer coming off or not being even or having gaps in it or all kinds of things. So keep an eye on it, especially during that first layer. But relatively speaking, this is a PLA print. PLA is really easy to print with, and hopefully this should just go nice and smooth. Alright, so now we're going to get into thermoforming this mask. And if you watch the Mark II video, you know I sort of very quickly pointed out that I have a heat gun, and then I proceeded to not use it and instead use water and a measuring cup to do the thermoforming. But for the Mark IV, I'm going to assume that you actually have some more specialized tools, including a heat gun. I'm going to show you how to use it. You're going to sort of find that it's much easier than other forms of thermoforming. But the other big difference between this and the Mark II is the Mark II, and for that matter, the original NanoHack mask, what we were trying to do is, first we were doing some technical bends, and then we were trying to thermoform directly to our face as best as we could. For the Mark IV, since we're actually going to be, we know we're putting a very specific TPU gasket on the back, we don't necessarily want to hit a perfect thermoform to our face so much as we want to hit a thermoform that's good for getting the gasket to fit to our face. For the chin, that's not really all that much of a consideration. For the sides, it's not much of a consideration. But for the nose area, where previously you would want to actually cut it in as close to your skin as possible and as close to your nose and really try to seal up your eyes and your nose, it may be a little counterintuitive to get too thermoformed to your nose and your eyes on the Mark IV because if you do it too closely, there's no room for the gasket. And keep in mind, after we install the gasket, this thing is still thermoformable. So if you find that you sort of messed up this step and you need to make some adjustments after the fact, it's still doable. All right, so what we're going to do is we're going to start with the technical folds. Again, the way this works, if you haven't watched the Mark II video, is the technical folds just get into a basic shape first. So I'm going to bend in the chin and then I'm going to curve it up. I'm then going to bend down this middle section and down the sides and curve them in. And then I'm going to bend down the two sort of nose/eye sockets pretty severely, and then I'm going to bend back up the nose area in that order. So heat gun can get a lot hotter than the hot water. It's, boiling water is dangerous, but this thing can be a lot more dangerous. You can actually burn yourself directly, but also keep in mind, if you're actually bringing it up to your face to sort of check fit or to actually even thermoform the sort of soft plastic on your face, be very careful because this thing can get this plastic a lot hotter than maybe you think it is, and you can burn your face very easily. So just be very careful when doing that, not to bring too much of a molten plastic to your face to the point that you're gonna injure yourself. But that being said, it is totally possible and reasonable to strike that balance of still having pliable plastic that's hot, that's not hot enough to burn you, and you can actually form it directly on your face. So here we go. I'm gonna start with my technical folds. All right, and there you have it. You may have noticed it was sort of a lot easier with the heat gun than it was with the water, which simply comes down to a matter of the right tool for the right job. It's not a perfect fit. I'm keeping it a little looser than I normally would because I know I'm coming in here with this gasket and I'll probably end up tweaking it later. But the basic folds are sort of in place, and there's really not much customization going on here besides the technical folds. I might close up. Well, you know what? I was thinking I might try to close up these gaps on the chin a little bit more, but I actually don't think it's worth it because I think I can fix that up pretty easily with the 3D printing pen, and it'll actually provide an opportunity to show you how much you can actually modify with the 3D printing pen when we get there. Okay, so I've gotten out my 3D printing pen because what we're going to do here now is seal up the seams, the 4 seams, the 2 at the nose and the 2 at the chin. In the Mark II videos, I used a hot glue gun to do this. You can still use a hot glue gun for this if you don't have a 3D printing pen, but again, in the Mark IV series, I'm going to use tools that are more appropriate, and I very much like the idea of using a 3D printing pen that's loaded up with PLA filament to close up seams in a PLA model. Now, this particular pen actually, when you use it stock, it's got a little LCD panel here and the whole 9 yards. It's actually a pretty good one. It wants PLA to go at about 190 degrees, but what I've found is that while it will print at 190, the PLA that comes out won't bond with pre-existing PLA at that temperature. And nor will it bond with the TPU, and later on we're going to be using this to bond with TPU. I've found that I have to bring the temp up to like 204, 205 degrees centigrade to get the plastic that comes out of here to really bond with existing plastic and to bond with TPU. Okay, so a hot glue gun and a 3D printing pen like this are actually not all that dissimilar. They're, very similar little devices, except of course this one's motorized and has a thermocouple in it. But what you're doing, which is just melting and spitting out plastic through a nozzle, is pretty darn similar. There you go. That's all 4 seams covered up. I'm going to let this thing cool off, and then we will move on to the next step.
All right, so the next step, and to be fair, you could have actually just started this the moment your other 3D print was done, but I'm putting it here, is to prep your TPU parts for printing. Okay, so the first thing I'm going to add to the build plate is the gasket itself. All right, there's the gasket. The next thing I'm going to add is the O-ring. All right, there's the O-ring. And then the third part for TPU that I'm going to put in is that flattened out version of the mask adjuster from HP. All right, and that pops in as well. And then I'm just going to lay them out, and we've got just enough room on the build plate for all 3, which is great. All right, so this is a much more difficult print, but actually here in the slicer, there's not much to do. Now, none of these actually need support. You can thank me for that later. Even with these pretty severe overhangs in the gasket, I've been very careful that none of these exceed 45 degrees. So it really, on my printer, I have not needed any support on any of these. So with that, all I'm really going to do is change things. I'm going to print out at 0.15 layer height. I think 0.2 would be fine. I just feel like it. My material is set to a profile for a particular semi-flex. Again, flexible filaments are difficult to print. If you have successfully printed flexibles before, then you know what settings work well for you, and you don't need me to tell you. If you have not printed flexibles before, you're in for a treat, because it can be very difficult. Some people are lucky and it just works, but it's usually pretty tricky to figure out how to actually go about doing flexibles. Infill's at 20%, but I don't think any of these things infill anyway. No support, so I am just going to slice it. And yeah, that's what that should look like. There's a tiny little bit of infill on that O-ring, but I don't think it matters. So yeah, I'm just going to export this to an SD card, and then we'll talk about the print.
Behind me here, we have a gasket that has just finished printing on my Prusa. But what I want to talk about for a moment here is the actual flexible filaments and what they mean for the design. So what I've been printing in is this Solutech clear flexible filament, which is either a TPU or a TPE, depending on who you talk to. It's difficult to get a real answer. But its main properties are it's really flexible, but it is not very elastic. Like, it gives a little bit when I pull, but not much at all. Okay. For comparison, this is a little waggly noodle of Ninja Flex, and it is even more flexible. But its big difference is when I give it a big stretch like this, it's really quite elastic. Okay. On my printer, the way it is now, I actually can't print the Ninja Flex. I'd like to, I can't. I can only print the Solutech. And that has a lot to do with the fact that it is less elastic. It has to do with the way that the Prusa sort of like jams the filament into the extruder when it loads and unloads. It's a Prusa specific thing, and it's just one of those many things that comes up when printers have trouble with flexibles. Even this printer has trouble with certain flexibles. The reason this matters is I designed this part to work with flexibles, but it doesn't actually require elasticity to work. Okay, I think elasticity would make it work better. It would be cooler, more effective, possibly even if you could actually print out of something with a lot more elastic. But it's flexibility that it needs, not elasticity. Okay, so if you're struggling to print this thing, and you're trying to find a way to make it work, consider the possibility that your choice of filament could help you. You can pick something that's flexible but not necessarily elastic, which might allow your printer to be able to print this. And keep in mind that the print itself, the design, doesn't need elasticity, it only needs flexibility. Okay, so with that, we're going to move on to the next step. Alright, so I apologize for this location. It's raining outside, and so I can't do this next step outdoors where I prefer to do it. Instead, I am here in my spare bathroom that I happen to use for sort of slop sink stuff on a general basis, sealing the surface of the Mark IV mask with an enamel clear coat. Now, the reason that we're doing this has to do with sort of some just conventional wisdom when it comes to 3D prints and food safety, which is a sanitary concern. 3D prints are generally considered not food safe because of the layer lines and the nooks and the crannies are areas where bacteria and viruses can sort of latch onto more easily and breed. And while theoretically you can wash them off and bleach them fairly constantly, it's still considered a significant issue. And there's lots of conventional wisdom about how you might go about that, including, well, why don't you 3D print a thing and then make a mold out of it with silicone and then cast it again out of food safe silicone and other things. But another thing that people suggest is sealing prints with materials that are more appropriate. As an artist who does a lot of work with 3D printing for artwork, I actually use enamel paints quite a bit to seal my prints anyway, because they kind of fill in the layer lines and smooth out the surface. It's sort of a low labor kind of way to go about it. So I am sealing the surface of this because I think it'll help. I think when it comes time to disinfect this thing on a sort of a daily basis with bleach and water, If it's a smoother, slick enamel surface, it'll disinfect easier. All right, so I'm using the ventilation fan in here to sort of vent the fumes. I'm just going to give it another coat and then walk out. I've got it in a spray box here to just capture the overspray and keep from causing too much damage to my bathroom. The mask is in there, and I'm just gonna touch up this coat. Yeah, I'm doing multiple coats, and I'm sort of turning it between coats. So, yeah, that's it. I'm gonna get out of here and let the fan vent the fumes while this thing dries. All right, before we move on to the gasket, I wanted to take a moment to talk about this other part that we printed out, which was the mask adjuster, which I had you print out of TPU. Those of you who watched the Mark II video may have noticed that I didn't suggest that anyone print out the mask adjuster for the Mark II, and the reason for that is because for the Mark II, I assumed the only thing that we had to work with was PLA. All right, now I don't think PLA is an appropriate plastic to print this part out. Now, I have printed one out here. It will print. I mean, here it is. This is PLA. I'll explain in a moment why not. And then this one, the red one, is actually out of PETG, and the clear one here is my typical flexible. Now, first of all, one of the nice things about it is it's really quite flexible and usable, in TPU. If you printed out a NinjaFlex, it might actually, since that stuff is softer and more elastic, it might not work because these hooks here for holding the rubber band might not actually be stiff enough in NinjaFlex. So you might have to, you might find problems with it in that. But I really like the way it works in the TPU. It's really, just the right mixture of sort of strong hooks and flexible back, and it hooks into your hair really well. It's great. I think it's probably fine in PETG because PETG is quite flexible as well. As you can see, it bends around pretty easily here. It's definitely going to be strong enough in the hooks. And we sort of know the properties of PET. It's even when it gets wet, it's still nice and bendy like this. The reason why I don't think it should be done with PLA is because PLA, it's hydroscopic, and that all three of these are hydroscopic. But when PLA actually gets water into its matrix, it becomes brittle, okay, and it snaps. I've had plenty of 3D prints just like snapping rather than doing anything else. And even if a freshly printed one is okay, I still think there's a strong likelihood that over the weeks that come, since this is quite thin, it'll pick up moisture from the air and become more brittle. And I think putting a lot of stress on one of these things with the rubber band and then all of a sudden it's snapping because it goes brittle would be sort of disastrous for just about anybody. And just to test that out here, I'm curious. This was only printed a couple of days ago, but I'm wondering if I try to bend it. And, oh yeah, it just snapped right there. See, I mean, just a little too much, and it went. It's a little thicker here, but it's already damaged. Let's try this other one. Yeah, that's kind of already, that's halfway broken apart, right? Again, the PET doesn't really have that problem. PET can take a lot more abuse. So if you really need to do it, PET will be a much better choice than PLA. See, in two pieces. But I really do like the TPU. Anyway, I just wanted to point that out. That's why it wasn't in the Mark II, but I think it's really an excellent thing for the Mark III. I think you could do better than this, but as a thing that already existed that I could just modify and print out, it's been working great for me. All right, so that's the mask adjuster and considerations for materials and printing and usage. All right, so this is the step that really makes the Mark IV the Mark IV. This is going to be the installation of the TPU gasket that we printed out. Now I've moved the camera in closer here, and I apologize. This is going to be really fine work, and I'm going to do my best to show it to you, but it's sometimes a little tricky to get all aspects of it completely visible. But before we get to the actual work, I want to talk about this gasket and the way it's designed and the way it's supposed to actually fit in here. So as you may notice, the mask is a complex three-dimensional shape now because we folded it, and the gasket is kind of flat and raised, which means that they wouldn't mate very well together just automatically, like that doesn't suffice. Just because this is flexible material, it doesn't mean that you can just jam it in there in any shape and it'll work perfectly fine. if you take a look at the structure of this thing, you'll see that there are various wedges taken out in places that make it sort of disconnect and relieve tension from when you bend it in various directions. And if you look really, really, really closely, you'll actually see that there are tiny little wedges cut into the inner rim across the nose bridge and around the chin. Okay, and those cuts are carefully placed such that when this thing gets deformed, tension is released, tension that would otherwise be there if it was solid. And they're also placed where, if you bend it in the right shape, the gasket actually sort of folds over itself and sort of makes its own seal. Okay, so as you go through this process, since I don't have a large variety of human faces to test this out on, I kind of have to assume that it's going to work on most people and hope that the changes that I made here aren't particularly specific to my face. And I wasn't really doing any measurements on my face, so it seems unlikely that it would just be mine, but you never know. One thing you can do if you're having problems getting this thing fitting to a particular shape that you need it to fit your face is you can mimic what I did here, which is taking little V-shaped cuts out of the parts of the TPU that were getting, when I tried to bend it to the right shape, were getting too taut. Like, if I try to bend this inward here, the outer part is actually keeping me from doing it, and if I put a cut or two into it, it would release that tension and allow me to make the bend. Keep in mind, every cut you put into it is a potential air leak. Try to sort of think a little bit about how this thing is going to form and see if you can get away with not actually putting extra cuts in it. But anyhow, that's how it's designed. Now, the other thing to keep in mind is that the basic form for this thing is that I expect both the nose bridge and the chin to sort of bend in a little bit. And you'll see when I bend those two in, the wings actually come in. And that's actually pretty analogous to this overall shape. So the intention here is that these two arches cinch in and the whole thing kind of then fits a little bit better, and then you just tack down the edges, the rest of it. Right. The other, and that's why there are cuts on the inner part on those two arches, because those, I wanted to give a little extra flexibility on those arches. They're very tiny. The other thing to keep in mind about this gasket is that at the base of it, the part that actually contacts the mask, it actually is sort of cut in on both sides. There are two little grooves in here that if you use your fingernail, you can probably feel on either side. And the reason for that is to allow this thing to be mechanically captured by the adhesive or by the plastic in place. That even though we're pretty sure the PLA at the temperature that I have it set, which is about 205 degrees, and I've tested this, the PLA does actually bond to the TPU at that temperature. I did have to turn up the pen, but it wanted to do 190 and I said no, 205. But even if you can't get it to actually bond and you're just dealing with an adhesive, the base of this thing is designed to have this little sort of foot, this sort of cleat that sticks out, so that when the adhesive sort of gets inside that groove on both sides, it'll actually sort of mechanically hold it there. All right, and so I'm going to choose, because this is the way I typically do this, I'm going to do a solid bead of PLA around the entire inner side, but I'm also then going to try to sort of after that get to parts of the outside and just sort of put little blobs at various points around to make sure that it's also mechanically held in place by both sides at certain points. All right, that's the plan anyway. So, all right, let's just get into this. And again, I apologize. It's difficult sometimes to really get in here with just my hand and the pen. So we'll see what I can do. So what I like, the hardest part I think is to get it to sit in the nose correctly, and to get it sort of affixed there. So I usually like to start there. And one approach, and hopefully it'll work for me this time, is to grasp the nose cup really sort of tightly at the top and just jam it in there as hard as you can. All right, and hold it with your thumb. Actually, and I'm using the wrong hand because I'm right-handed. So we'll try that again. I'm just gonna grab the nose, find where I want to just jam it as high up in there as I can go. Centered. Just jam it in there, force it against the plastic, and then pinch it with my thumb. And now if I could just get my 3D printing pen right in there, I could actually tack it in place. Right, and that's the plan. That's exactly what I'm going to do. So I'm going to start my 3D printing pen heating up, which is going to take a minute. And you can see when I do this, these two flaps, which are sort of for your cheekbone, you know, sort of transition to your eyes, actually sort of cut in, and the split is being covered up, and they're sort of standing like straight up, which is what they should do. When you get this thing in there, right, those things actually, there's a strong bend right here, and those two pieces get in the right place where they sort of, the ring covers itself, and the two flaps really sort of stand up and get away from the rest of it, so that when you put it on, they can really sit flush with your face. And now I'm also keeping my thumb a little bit back from the edge, because this is hot plastic, and I'm gonna have to hold this thing here while the plastic sets. So I don't wanna get so close that I'm gonna burn my thumbnail. All right, so here we go, we've got temp. I'm just gonna start the filament going and wipe off on my parchment paper here, and fail to do that and make a mess. And with one hand, do a really bad job of just trying to clean the nozzle away. Screw it up a few more times, and then give up and just try to create a big blob on the paper and see if I can use that to wipe. Good enough. All right, here we go. It's gonna be ugly. You're gonna end up with plastic in all kinds of places you didn't mean it to go. And you're probably gonna have to do it like 3 times. Just like I just messed up. And that is okay. That is okay. All this stuff is still somewhat melted. I'm just gonna pull it out. And we'll try again. And that, again, that is okay. It'll be easier once we actually get this thing initially tacked in. And it is worth it, by the way. Once we get there, it's worth it. You get one heck of a seal on this thing when it's really in there. Right now I just jammed that thing in there really hard, and hopefully it's really going to take and you know, spit plastic. And it's ugly in there. I don't know if you can see it, but it's okay. Alright, I'm going to slowly let go, and hopefully maybe we have just a good enough. Alright, it is roughly staying in place. That means we have a fairly decent bond. It's going to be next. And now I'm going to try to augment that thing. You'll get it. Yeah, yes. Now that you'll see it. Yeah, right. Again, this is probably the hardest part of the mask, is really these tight turns around the nose. It's just incredibly difficult to get plastic in there because the pen doesn't really want to, even though it's much more precise than a glue gun, it just doesn't want to get in there. All right, now that is a good amount of plastic really holding the edge of that TPU in there. So now that you've got the basic nose in place pretty well, and we're not going to put too much stress on it, but we want to now hit the second hardest part, and this is really just going to set the TPU. The rest of it will be relatively easy after we do this. That's going to be the chin here. See, by default, it wants to go way off the end here and into space, and what we need to do is we need to sort of force it to come in. Here, I'm going to put down the pen so I can flex this better. We're going to force it to come in and sit flat. Right? And when we do that, the other parts of the mask actually bend. And ultimately, when we get it right, let's see, if I grab it from the edges here, it actually comes in easier. And that's actually the key to this, is when we really get this right, we're actually going to set it in place kind of like this, where we're pushing in, and that helps it angle up. The whole and you have some options here, and actually in this case I think what I would rather do is actually, since I'm holding this, I'm just going to let go of the right side, let the left Pen is ready to go. Set both sides, push them in, find the place. Right. There we go. Let's see if I can just get. All we're trying to do is tack it here. Wow. Alright, there we go. Now since I can, because I'm right here and I can kind of see it, I'm actually going to hit it on the other side. Yep. I can actually see the edge here on the other side, so I'm just going to use this opportunity to lightly jam some filament down in there, make a blob, and then press it down into place. Because it was visible and easy, and finding places to get in there once you really get this thing tacked in is sometimes difficult. All right, so that's actually tacked into place. This part side is in the wrong place now because it was moving, but we're just going to flex it down into the place that we want it to be, which is going to bring the chin into the right position. And then we're going to tack that in. Trying to get under this inner rim. Since I can and since it's in the right place, I'm just extending because it's like right here and it's already in the right place. I'll come back and really shore that up, but that should guarantee me that this whole section is really going to just stick there. And now the middle section is sort of, it's got tension on it from both sides, so it's going to stick. So now we can just sort of lay it exactly where we want, and we can actually get at this entire inner rim here because it's now actually sitting flat on the plastic because we tacked it on both sides and added the tension to put it there. Alright, so that's the two hardest parts handled. Now the rest of the mask we're just going to continue around this rim in here, which is relatively easy to do despite all the stringing, along that side, and then we're also going to continue along this side. Obviously just keep clear of the grill, but it's usually relatively easy to get both of those to function. So I will just implement and but I would say that's good, and you should be able to give it a little bit of a tug, and you'll notice it doesn't come. If you're getting it right, it doesn't come off. All right, so first of all, it's really easy to just bend certain parts of it up that will allow you to, and just do the mechanical seal on the other side. Right now it's like jammed between two significant pieces of PLA and it's just not going anywhere. So pick your spots. You don't need to actually seal the entire outside of it. Just sort of Alright, so this thing looks like a mess, and once it's sort of cooled off, you can take a scissor to it and trim off all the hairs and all the sort of like little extra bits that it didn't quite work, and it'll start to look a little bit better. But there you go, that's attaching the gasket. The thing to keep in mind here is I wouldn't really test it right now until you trim all that stuff out, but the next thing you'll want to do is you'll want to test the fit. If it doesn't work for you, if you can't quite get it to fit the way you want, this whole thing is still thermoformable. Alright, so you can take the heat gun to it again and sort of, now that it's attached, you can sort of bend the whole mask back to make this thing fit better than necessarily it does after this first little attachment. So there you go. That's one gasket attached. All right, I want to talk about filters and filter materials, and then we're going to make some filters. But before we do that, we need to talk about this research paper. It's by Anna Davies et al. And it's important to understand what this is telling you about various household filtering materials and their efficacy. You should read it in its entirety, but I'm going to quickly sort of the most important part that we can get to, which is this table here. Okay, and this lists a bunch of household materials and also their control, which is just a surgical mask, which is made of medical grade nonwoven polypropylene. And it tells you how effective it is against a standard sort of bacterial size and a standard viral size. Okay, and that's the two main sections of columns. And then the third thing over here is really important too. This has to do with the pressure drop across the fabric, which is another way of saying how difficult it is to breathe through it. Choosing an appropriate filter material that, first of all, that you have in your home that is available to you is sort of a combination of both of these things. First of all, when it comes to COVID-19, clearly we care more about the viral column than the bacterial column. But that being said, even the actual surgical mask is only roughly 90% effective against the viral payload that they tested. And each of these other materials has, is in the same scale. It's filtration efficiency. Some are better than others. But you can't just pick the one that's closest to best and expect it to work, because this other column, having to do with how difficult it is to breathe through them, has serious effect, especially when it comes to our mask, which may not have the best seal that is possible. If the filter material offers too much resistance, we will blow through the seal. And so really what you need to do is balance these two and come up with an appropriate balance for yourself. What I like to do is single ply, though I'm going to show you how to do dual ply, but I like to do single ply, either 100% pure cotton from a t-shirt or cotton blend from another t-shirt. So what I'm going to do here first is I'm going to grab a single ply filter holder. I printed out a bunch of these. I realized that when I demoed it I only did one, but you should probably print out a bunch. We have the inner ring and the outer ring, and there's a gap between them that's just the right size to sort of jam some filter material in there. So this is a piece of 100% pure cotton fabric from a t-shirt that I have bleached, so it should be fairly clean. And the way we do this is we place the filter material over the inner ring, and then we capture it with the outer ring, and then we trim away the excess. But one thing is really important to recognize from this research is that they point out that they did not pull any of the fabric tight. And in fact, if you hold up the fabric and sort of stretch it, you'll see that you're kind of opening up the holes. So it's not good enough just to capture it here. We need to make sure that we sort of leave a little slack in it. If it ends up like a trampoline when we're done, then we're probably pulling the fabric tight, and that's probably making it less effective. So we're going to put a little slack into it before we take the outer ring and put it around the edge. You can do this a few times. It's not the most critical thing in the world if you get it wrong. And then press down until it really captures the fabric. Let's make sure it's not actually tight in there, that it's still sort of got a little bit of slack in it. And now that we've captured it, you just take a pair of scissors and trim around the edge pretty close. Like all of this has to kind of fit in the filter cylinder. You can leave a little excess around the edge because it'll actually help with the seal, just in case any air wants to try to get around this thing. Having a little extra fabric can't hurt too much as long as it doesn't jam the thing in there. All right, and there you go. That's a perfectly functional filter, captured, and you can breathe through it. Okay, and this is 100% pure cotton. Doing the same thing with any other material is pretty trivially easy. But I'm also going to show you how to make a 2-ply filter and this one's going to be a little different, and there's some caveats I need to put to this. Okay. So the reason I'm going to do this with a layer of nonwoven polypropylene, which is not medical grade. I got this from a reusable shopping bag that I know is made from non-woven polypropylene, but I don't know if it's medical grade. I don't know the size of the pores in this material. I just know that it's a type of non-woven polypropylene. And so if I were to just use this alone in a single ply, it would be pretty risky because I really don't know if this is filtering any virus at all. So what I'm going to do is I'm going to try it on the hopes that maybe it's useful, but I'm going to put another filter material behind it that I know is at least minimally effective, so that if this thing is completely useless, my other filter will catch some minimum number of virus. So I'm going to use my cotton blend material, which is just from a different t-shirt that's a cotton blend, behind the non-woven polypropylene. Now, this filter, as you notice, it was a different file, and if you look really closely, you'll see the gap between the rings is significantly wider. It's just about right to capture 2 layers. So as I said, I'm going to back this with the poly blend. So I'm just going to put it in there and put a little slack in it so that it doesn't get pulled too tight. And then I'm going to cover it with the non-woven polypropylene, which doesn't stretch, so we don't have to worry so much about pulling it tight. And I'm going to take that outer ring and capture them, push it over the top, and it grabs them both pretty tightly. Let's check the back, make sure that the cotton blend isn't pulled too tight, and it's not. And do the same thing. Grab the scissors and cut around the edge, staying pretty close but not being too obsessed over it, because a little extra fabric may help sort of form a little gasket or a O-ring on the side anyway. So just trim around, and there you go. This is a 2-ply, and if you try to breathe through this one, you'll notice it's harder to breathe through, like it's significantly harder. And as stated, this kind of filter is more what I would use in the Mark IV with a much better seal, but you might be able to get a good enough seal on a Mark II to use one. So, you know, have at it. Again, read the material, be informed, be smart, but, you know, here's a design to use these kinds of filters in this kind of mask. Okay, so here it is. This is the Mark V with the gasket in place. It's pretty much ready for final checks and final assembly. I just want to point out the best way to, or 2 things about this. One, unlike the Mark II, there is sort of a better way to put this on than just sort of throwing it on your face. If you can slot your nose up into the nose slot, it has a tendency to find a better fit. So, sort of like that. You know, if it helps sort of set the flaps in the right kind of place. Second thing, you know, when testing this thing out for fit, you have a tendency to want to put your hand in front of the cylinder and feel for the hot breath, which is a perfectly good thing to do. If you're out in the wild, however, you should never do that, because if you are exhaling, you could be blowing live virus off the front of the filter and onto your hand. But in this somewhat sanitary environment, and when you're doing your last fit checks, you know, it's a perfectly valid way to go about it. So what I'm going to do is I'm going to put this thing together, including the filter, and then we will just make sure that it's working the way that it should. Now, keep in mind, it is still thermoformable. If the fit is not right, you can still adjust it and get a better fit. So I'm going to grab 2 rubber bands over here. Now, if you watched the Mark II video, you may recall that when I sort of put rubber bands on here, I sort of said they were good, but they weren't great, and we moved into all kinds of optional things to do with the mask to sort of get more tension on the mask, get a stronger fit on it, which included a completely different sort of strap solution. But for the Mark IV, I found I don't need to do any of that. The mask adjuster and the rubber bands combined provide sort of all the tension I really need to get this seal to work very, very well. And it's partially, you know, the strap adjuster, but it's also, you know, it's more really that the seal is actually good enough that you don't need to put tons of pressure on the front to try to fix it. Okay, so I've got the 2 rubber bands on. I'm just going to grab the strap adjuster and just quickly loop it around here. And that is, again, sufficient for tension for this thing. And now we're going to just assemble the filter in the filter chamber. Okay, so I'm going to grab the cap, I'm going to grab a filter, and I'm going to grab the O-ring. Okay, and I'm going to put the filter into the cap with the standoffs facing forward so they can just sort of keep it from hitting the front. push it all the way in. I'm going to put the O-ring on there, and then I'm going to take the whole thing and just screw it into the cylinder. And it'll tighten up because the O-ring is going to hit the end there. Okay, and now I'm just going to put the whole thing on, and we'll see if we get a good seal and if the air comes out of the cylinder, which it should. All right, now my glasses make this more complex than it needs to be. There we go.
Okay, there we go. Perfect seal. Nothing coming out of the bottom, nothing coming out of here, nothing coming out of there. Everything coming out of there, which is exactly what it should be.
All right, so this is the Mark IV. I hope you found this video useful for the assembly, and I just want to repeat my disclaimer yet again because it really is important. I am not a scientist, I am not a medical professional, I am not an engineer, and I really don't know if this design is actually functional or if it might be dangerous. But I am providing it and this information in this sort of emergency situation anyway, because we don't have other options all the time. So there you go. I hope this video helps someone somewhere. Thanks. Have a good day.